Hey everyone, welcome to this tutorial about MLFlow and experiment tracking for TensorFlow and some other libraries as well. Feel free to follow along. All the code is in the GitHub and the link is down below. Just keep in mind that some parts might take a bit too long to run, so it might be best if you take this as an example, follow the syntaxes, and then apply this to your own project. Okay, now let's begin. So first things first, let's go into the GitHub page of tutorials that I have here, and I'm interested in getting these two notebooks. So what you can do, you can just clone it like this, and then to git clone, and then paste the link that we've just copied. As you can see, I already have it. So here I have on my local machine these two notebooks, and I even have them opened in the Jupyter notebooks. So let's just do a quick run through. You don't really need to understand much that's happening here, but the most important parts are that, first of all, I'm getting the data, I'm doing some pre-processing, and then I'm running a bunch of different models trying to predict the test data set and then recording the test metric, which is root mean squared error, in these separate variables. So I'm doing a random forest, I'm doing a CatBoost, and then variations of this very fancy transformer architecture for tabular data. I have a whole blog series about it if you're interested in, but basically I'm doing the same thing here. So I have some sort of training happening, and then I'm doing the predictions for different variations of it and storing the results in in just different variables. And the main output of this notebook is this table here. Well, not table, but the printout. As you can see here, I'm attempting to compare different models and looking at their RMSEs. So why is this bad? Is because I have no recollection of what happened before I got these values. So did I run experiments multiple times? Which parameters did I use? I can try to guess them from the parameters that I specified here, but nobody would tell me that because I don't know, changed it to 50 here and then just saved it because I wanted to run the experiment, but I didn't. So nothing really tells me that which parameters are responsible for this specific metrics. So this is what experiment tracking is supposed to fix for us. It's supposed to tell us which parameters have led to this specific results, and even it can save us some model artifacts, maybe models themselves. So it's really useful and I really recommend using it. And this notebook has refactored this code and started using the MLFlow experiment tracking, which I'm going to tell you more about. Let's go to the command line, and here I'm using a virtual environment called blog. So for me, it is already activated. So what I'm going to do, I'm going to just pip install MLFlow if you don't have it yet. I already have it, so it's going to be, quite simple and quite fast. I would say it's quite a friendly package. It doesn't have any weird dependencies, so it should be working with your environment as well. Now, when I've run it, the first thing that I want to start running is the actual MLFlow UI, which is quite useful when you're tracking the experiment. And to call the MLFlow UI, so it's going to be the command MLFlow UI. And then we also need to specify which database we're going to use to store the experiment results and different artifacts that we specify. So I think the command is something like backend store URI, and then I need to specify that it's a SQLite, and then MLFlow.db. So this is going to spin up an MLFlow server, which is going to be showing you and tracking all of your experiments, which is super neat. So let's copy and paste this link to a browser, and there we have it. Okay, so this is the MLFlow UI, which is going to be your entry point to the experiments that you run. As you can see, it has two tabs, experiments and models. We don't touch models for now. But what we can see here is that we have one experiment which is called default, and it has no runs. So this is created automatically for you. Now what we want to do, we want to create our own experiment run and to specify, first of all, what its name and which parameters do we want to store in it. And now let's go back to the code. And I will show you how to do this in this refactored notebook. So as you can see, we imported just like this, and import MLFlow, and this part is important. Okay, one second, let me specify which kernel I used to run it. So as I said, I used the virtual environment block, so I'm going to use the same kernel to run it. Now let's import all of this good stuff. Might take some time. There we go. Imported everything, just setting some parameters. So this is the first thing that is important to get right. So the set tracking URI, so this is going to be the database that we've kind of specified before. And as you can see, MLFlow has created it for us already. It is here, the same folder where you run the experiments. So we specify it here. And then this set experiment income. So this is the name of the experiment that we want to run. I call it income because this is the income data set. But yeah, like you can call it whatever you want. And it has created. So as you can see, it's smart enough to know that there is no income experiment before. So it has created it for us, which is super nice. So let's load all the data. Let's pre-process it. And first thing you can see here is that we have this option to autolog. So MLFlow has different integrations with different libraries. So it is Sklearn, LightGBM, CatBoost, TensorFlow, PyTorch. And there is a lot of like parameters which you might want to track, and it lets you to track them automatically. But in this case, we don't want to run it. So yeah, we're not going to autolog it. And instead, we're going to do this manually. So how to do this manually is, first of all, every experiment is run in the context. So when you specify with MLFlow start run, you specify context of the MLFlow. And first of all, the first parameter to specify is the run name. So the run name for us is going to be here. It's going to be rf baseline. So that's a random forest that you can saw as you saw in the previous notebook, which was not that well formatted. You know, just like the training and the predictions. So did all of these steps without any of the logging. So now to do the logging, there is few things that we need to do. So first of all of the logging starts with MLFlow, and then we call different methods of MLFlow. So the first useful method to do is the set tag. So this is kind of like a custom elements of the experiment run that you want to specify. So here I'm going to set tag of the model name, and it's going to be random forest. So because my main purpose here is to compare different architectures between each other, so random forest, CatBoost, deep learning models, I want this tag to be there. So that's going to be the first one. And then log params lets you to log multiple parameters if they're stored like this, if they're stored as dictionaries. So I can log automatically number of estimators and maximum depth. Again, so this is done so that I remember which parameters led to a certain result. If I don't do this, then it will not get logged, and this information will be lost, and I will not be able to recreate the experiment or to communicate it clearly to my colleagues. Now, okay, so I log the params, I do the random forest, I specify the random forest, I specify the fit, do the predictions, do the calculation of the metric, and then, as you can guess it, so log metric logs the metrics that you want to your experiment to have. So this is I'm going to call it test RMSE, and then this log model. So this, as you can notice, this is a specific to Sklearn because there is different ways to save models, and a lot of them are different between different libraries. So what you want to do, you want to usually see if there is specific methods for the library that you're going to use to save your model. And in this case, it's an Sklearn model. So I want to log this model using Sklearn, and first argument to specify is random forest, and second argument is just the path of the artifacts. It's nothing fancy, so I'm going to just run it and going to wait until it finishes running, and then we can see in our UI how the experiment looks like. Okay, so it has finished running. Now let's go to the MLFlow. Let's update it. So as you can see, the experiment income was created. And here we can see the run name that we have also created, which is called RF baseline. So there is not much here, but what we can do, we can add metric, and we can add a model name because that's what I'm interested in. So yes, test RMSE is 0.5, model name is RF. You can also click on it and you can see different parameters that we stored. So the max depth was 20, number of estimators was 100, metrics, tags, and the artifacts as well. So because we chose to save the model, we can actually load it into our environment later if we choose to. They even give you like a few useful snippets on how to do it. So yeah, we can explore it a bit later. But for now, it looks really awesome, right? We didn't need to do much, just specified a few parameters, and it has logged a bunch of stuff for us. So that's, I would say it's a really good workflow to adopt, and it also makes you a bit more consistent with the way that you specify the parameters and the way that you log your experiments. So let's go back then to the training and try another model. So this is going to be CatBoost. Now for the CatBoost, we need to specify a specific dataset type. Again, not that important for this. And here we can see again, so we're specifying a new experiment run. Now this one is going to be called CatBoost. Again, I'm setting a tag to the model name, CatBoost, because I want to compare them and want to train it, want to predict, want to test, and log the metric and save the model. So the same workflow as we had before. And as you can guess it, if we go here, you can see that it already knows that something new is here. So we can refresh it, and here is the CatBoost. So the test RMSE is lower, and we know that this model is better. We can even click on it, download it if we want, and use it in our kind of next steps. Awesome. Okay, so now the other things is, so we want to know how to use it with TensorFlow, and luckily for us the procedure is mostly the same, right? So we still want to do tags, we still want to do parameters, we still want to save the model. The only thing that changes here is you need to be a bit more you need to be a bit more consistent and a bit more structured with the inputs that you provide. So let's start disentangling this bit of code here. So first of all, when I run this function, I want to specify a name. So this is the experiment run name as we did before, right? It was CatBoost RF baseline. So this is going to be something like MLP1, MLP2. Now the MLP parameters, so this is the first set of parameters that I want to store, and these are the parameters of the architecture itself. So this is going to be a number of neurons in a dense layer. This is going to be an activation function of a dense layer, and it's going to be a dropout rate between different dense layers. And as you can see here, so we're going to end up having 1, 2, 3, 4 parameters, and they're mostly, so yeah, 3 of them are about, no, sorry, we're going to have 5 parameters, and 3 of them are going to be about this number of neurons in the dense layers. So this is the first parameter. Now the second parameter is second set of parameters that we want to store is the training parameters, and because to train neural networks, they're quite sensitive to the training parameters such as like learning rate, early stopping rounds, weight decay, and all of the good stuff. So we would also want to track it and to store it so that next time we can recreate this experiment. And as you can see here, so we pass them into the train and MLP function together with already kind of specified MLP parameter, MLP architecture. And as you can see, it has a learning rate, it has a weight decay, it has number of early stopping rounds, and it has a number of epochs. So that's the parameters that we want to store. Maybe we would want to tune them as well in the next runs. So yeah, that's what we want to do here. And now let's see what we do here. So we store these parameters as well, so we log them. They're going to be logged together with these MLP params. Then we want to set a tag, again, because the main purpose is to compare different architectures. Then we're going to build the MLP. We're going to train the MLP. Then we're going to make a prediction on the test and then evaluation of the RMSE on the test data. And then the same thing as we saw previously, so log metric. And then the TensorFlow has its own log model method, so the same way that CatBoost had, the same way that Sklearn has, and we're going to save this model. So yeah, that's basically it. To do this required us to think a bit differently and not just like define model and then do training and then forget about it, but instead try to modularize it so that it takes the parameters that we want as inputs and does what we want as an output, because it makes it so much easier to store these parameters if the function is defined really well. And let's define some of the parameters. So first of all, this thing just specifies what is the training data, what is the validation data, and what is the test data. It is a bit different from all the other ones because TensorFlow has its own data set structure. Now the MLP parameters, the ones that I talked before, so this is the size of the first layer, size of the second layer, size of the third layer, a dropout rate, and an activation. This hasn't been done using some sort of hyperparameter tuning, so feel free to adjust it yourself. So this is the train parameters, again, which are going to be stored. So the learning rate, weight decay, early stopping patients, and number of epochs. And the only thing that is left to do is just to run this function that we've defined. So I specify that it's going to be MLP base now and specify all of the parameters that we did here. So yeah, let's just run it. It's going to take some time to train. Perfect, the model is saved. So as you can guess, we go here, we can see something new, and this is the MLP base. Perfect. So yeah, we can see that it performed worse than even random forest baseline. So maybe we want to change something about it because, I don't know, we're not happy with the results and we believe that MLPs should be performing much better on this task. So what we would end up doing, because we've set up so nicely, is basically just copy paste this one, specify it as MLP params 2 and MLP base 2. So this is going to be second run, and now let's try something simpler. It should be like quite a simple task to do, so maybe let's just do all of them like 64 and maybe reduce a dropout rate. I don't know, I'm just guessing, but using this, what it should be, so as you notice, we just changed a few things here, and it should keep training it until it's done. And if we go here, so we can see that it has started the second run, and when it's done with it, it should save the model and it should show us the metrics. Then we'll be able to compare both runs and we can see what is different between them. So that's quite a neat thing that MLFlow does for us. Let's wait until it saves the model. It's also not really mandatory to save all of the models, because if we save all of the kind of parameters properly, you can recreate it, but I just found, yeah, that the saving functionality is quite neat. So maybe let's let's update this one. Should show that it's been, yeah, it took a bit longer to train because the model was simpler. As we can see, okay, so here test RMSE got smaller, so that's a good sign. And now what we can do, we can just select two of them and compare them between each other. There's like quite a few plotting functionalities to do, but it makes more sense to do when you have multiple experiments, like 20 or 30, then you are going to end up with pretty nice plots. So in this case, what we want to do, we want to just look at the table. So as you can see, yeah, we close the visualizations, close the run details, so just the parameters, and let's just show the differences only. And basically we can see here that, so the layer 1 and layer 2 sizes differ, and then the dropout rate differs, and then the test RMSE is lower. Model name is the same, so that's what we wanted, and this way we can consistently evaluate experiments and make sure that we end up with the best model. So quite neat, right? Now, okay, I went back. So we have all of them still here. Now let's go to the models that kind of this tutorial before was focusing on. So they're called FT transformers, feature tokenizer transformers. They're really powerful architecture models, and we want to see how they perform. So again, let's transform the data into the appropriate format. And now we are ending up doing the same thing like we did for MLPs. So we have separate functions for building the model because we want to save the architecture parameters. We have a separate function to train the model because we have our train model parameters. Except in this case, we're also going to have parameters to skip. So these are the parameters that are not that important, and I don't want to be storing them. But as you can see, they're still required to build an FT transformer encoder here. So we have these two functions. Let's define them. And again, the third function is going to be FT transformer MLFlow run. So that's the same function that we did for the MLPs before. And we specified the name, we specified the model, we specified the tag, we specified the parameters, and log the metric and log the model. As you can see here, so I was trying the auto logging as well, and it is quite a neat thing to do. I just didn't find it that useful in this case, but you can explore it yourself, or maybe I'll do a tutorial next time about it. So let's run this, and let's actually specify the parameters to train and parameters to skip, and then I'm also going to specify parameters to save. So yeah, lots of different parameters, all of them kind of get saved. And to find out more about them, again, please go to the blog post that I did about these models. Super interesting. They might be, the future of tabular deep learning, who knows. And let's just train the model. It's going to take some time, so you'll probably see a time skip here. Alright, so while the final model is training, let's go here. We can see that there is 4 new runs. So the first one is linear, the second one is periodic, quantile, and the target one. So the target one is not done yet, but what we can see that the test RMSE looks actually pretty decent, especially for the PLE quantile. It's 0.456, which is just a bit lower than CatBoost. So what we can do now, we can actually select 3 of them, and let's again just compare them. So you can see that having 3 models is already more fun. You can see some interesting visualizations. So first of all, the test RMSE, you can see this is our favorite, the PLE. Now what we do want to, this is actually, again, we don't have enough models to compare them visually, but instead we can show the difference in parameters. So you can see that the linear doesn't really take numerical bins as a feature, and we can see that PLE does and periodic does. So yeah, just by looking at this, we can see that PLE indeed delivers better performance here. We can also wait until the last model finishes training before we can get another set of features, and we can see which one is going to be better. But yeah, this is pretty much all we wanted to see. So if we can go back, we have this visualization at a glance with different model names with different parameters. So in this case, I would probably want to add to add the embedding type. There we go. Just to differentiate between the FT transformers, and having this view of the experiments is kind of similar to what we had in this notebook, right? In the old notebook, but instead now we also have test RMSE, we have all of the models stored, we can get all of the detailed parameters if we ever wanted to. We can also see the duration of training. Once it's done training, I will also show you how to reload these models from these MLFlow repositories. Our final model has finally finished training, so we can go back here and we can see that the PLE target is now listed as 0.447 test RMSE, so it is actually the best performing deep learning model, but you can see that it took significant time to train. So okay, this is it basically for the training and logging. And now what we might want to do once all of this is done is to load our best model. Because we've been saving all of them, it's quite easy to do with MLFlow. So what we need to do, we need to go to the model, And then in the artifact section, you're going to see this example of how to load it. Actually, TensorFlow models have their own methods. So what we're interested most is just copy pasting this ID and then going here. And as you can see, I already loaded it here. You can just copy paste it here and then load the model. So this particular model, if you actually decided to go and train it with me, it's going to take quite a long time to load just because it's quite a chunky model. My laptop is really bad, so you might want to choose other model to load, or maybe yours will be much faster at it. But basically, once we've loaded it, what we can do, we can use it as our regular TensorFlow model. It has a predict method, it has everything else, and yeah, so once this is done predicting, we will be able to get our output. So it gets stored in the output, and then maybe we can even do a this plot. Okay, it is done predicting. Now we just plot it, and here we have it. Okay, perfect. Well, this is it for this tutorial. I hope you enjoyed it. I hope you learned how to log your experiments. So just to reiterate, there is a few things we can log. We can log the parameters, we can log the metrics, we can log the tags, and we can save the artifacts, the models. Artifact can also be basically anything, like for example, a standard scalar that we defined in the very beginning of the notebook. It can also be a nice artifact to store if you want this experiment to be truly repeatable. So this is it for this tutorial. I hope you learned something new about MLFlow. I definitely have. Seems like a really great tool, and I will try to use it more in my next projects. Maybe I will find out new things and I will share them here. But if you liked it, don't forget to give it a thumbs up and to subscribe. I hope to start posting quite regularly, so there is going to be always content for you to enjoy. Take care, bye.